It's summer sale time. We're giving podcast listeners an amazing 50% off an annual subscription to New Scientist.
It's an incredible deal. You can get unlimited access to all the articles on newscientist.com for under £50 in the UK or $50 in the US.
Go to newscientist.com/pod50 to get this bargain. Hello and welcome to New Scientist Weekly. I'm Penny Sarche.
And I'm Chelsea White. On the show this week, we're looking at a breakthrough in boosting crop photosynthesis and a new way to try to predict earthquakes.
We're also going to be contemplating long-termism and hearing about a place in our solar system where the snow falls upwards.
What a show. To talk about all that, we're joined by Leah Crane, Michael LePage, Alex Wilkins, and Carissa Wong. Hi, everyone.
Hi.
Hey, how you doing?
Hi.
And we'll get things started first with news of a potential way to treat and maybe even prevent food allergies using a molecule made by gut bacteria. Carissa, what's the story?
Yeah, so this story basically centers on a fat molecule called butyrate. And basically, we already knew that some gut bacteria produce this molecule and that people with food allergies tend to have fewer butyrate producing bacteria in their guts. So basically, that hints at a link between these bacteria, butyrate, and food allergies. This idea has been supported by almost a decade of evidence from mouse studies too.
Right, so that sounds interesting. Does it mean we can just give people butyrate to treat their food allergies?
Well, there's a slight problem, which is that it has a really awful smell. So it's been described as smelling like dog poo or like rancid butter, which basically makes it pretty unappealing to swallow. And then
That sounds really appetizing, doesn't it?
Yeah, and another challenge is that when you take butyrate orally, it breaks down before it actually reaches the lower part of the gut where its benefits will take place. But luckily now researchers have overcome these two challenges, and that's by packaging this foul-smelling butyrate into tiny spherical polymer capsules called micelles. And this micelle packaging basically masks the smell and also allows the butyrate to reach the lower gut to take effect.
Well, that sounds great. Do these micelles actually reduce allergic reactions?
Yeah, so the researchers did test this, and they found the butyrate carrying micelles could reduce peanut allergies in mice. To test this, they treated 80 mice with an antibiotic to reduce their levels of butyrate producing bacteria in their guts. And then they induced severe peanut allergies in the mice by feeding them a peanut protein along with an immune stimulating toxin for a month. And then once the mice had developed these peanut allergies, the researchers gave half the mice a control saline solution and the other half of the mice daily doses of the butyrate-carrying micelles, and that was for 2 weeks. And then when they exposed all the mice to peanut protein, the control mice developed a severe immune reaction called anaphylaxis, but the micelle-treated mice didn't.
So how long did the benefits of the treatment last? Like, if it works in people, would you have to keep taking the micelles forever?
The researchers didn't look at really long-term effects in these mice, but they did find that the micelle treatment increased the amount of butyrate-producing bacteria in the guts of the mice, which suggests the treatment can stimulate the microbiome to actually produce more of its own butyrate. So when I spoke to a researcher, they said the team hoped for a scenario where someone with allergies could take the micelles for, say, a month or so, and then that could alter the person's microbiome to prevent them having allergic reactions in the longer term. But this needs to be tested still.
So it means that, if it does work, it could treat people with allergies, but potentially could also be used to prevent someone developing allergies in the first place, maybe?
Yeah, so that's speculation at this point, but the researcher I spoke to did say it was possible that in the future someone could have their microbiome analysed, and if they had a deficit of these butyrate-producing bacteria, they could take butyrate-carrying micelles possibly as a preventative measure to alter their microbiome and prevent allergies ever developing in the first place. But again, it's important to note this hasn't been tested yet. And the researchers also imagine that the micelles could just come in a packet that you add to a drink. Again, that's not happened yet, but that's sort of what they're hoping.
Yeah, well, that sounds easy enough. Nicer than the awful smelling pills.
Yeah. And I'd say, like, the other key part to mention is this treatment could theoretically work for any food allergies, not just peanuts, because the way the treatment works isn't specific to a food type.
Do we know if or when this will be tested in humans?
Yeah, that's a good question. I mean, the researcher I spoke to said the team hopes to start testing the therapy in clinical trials within a year or two.
Next up, we've got the discovery that earthquakes occur less randomly than we thought. Alex, can you tell us more?
Yeah, so this week I've been looking at the simple matter of whether you can predict earthquakes. It's an absolutely massive area of research because it could prevent millions of deaths and billions of pounds in damage. But there are so many different competing theories about how predictable earthquakes really are. There's this long-standing problem in earthquake prediction where researchers want to know if you look at the records of previous earthquakes, whether you can get information about future ones. And until very recently, the conventional wisdom was that earthquakes were basically just random.
So does that turn out not to be the case then?
Yeah, it seems it might not be. So John Rundle at the University of California, Davis, and his colleagues have taken these techniques from economics and used machine learning and showed that prediction from past earthquakes is actually possible. It's more similar to the sort of predictions you might see in weather forecasts, so assigning a certain probability of an event in a certain region over a certain period of time.
I gotta say, as someone who lives in the Pacific Northwest where earthquakes are a real concern, this sounds very exciting. So, how exactly did they do this?
So there's a few different advances that they've used to help them show that earthquakes aren't random. First, they looked at the rate of earthquakes occurring in a certain period of time rather than just the intervals between them, which researchers have traditionally used. They then put their machine learning model to work and looked for patterns and used certain statistical techniques to assign future probabilities. They then did this for a 50-year earthquake record in California, which is one of the only places that collects really high-quality, detailed data about seismic events. And they managed to produce predictions that sort of say things like, there's a 90% probability of a major earthquake in the next 3 years, things like that.
Wow, so how accurate were these predictions?
So the team used a metric that is traditionally used by meteorologists. It's something called skill. That they compared their predictions with historic California data that they hadn't yet fed into their model and found that the earthquake model was significantly better than random chance, which is what this skill measure measures. The algorithm scored 0.708 for prediction skill. That's on a scale where 0 is always wrong, 0.5 is no skill, so basically just random chance, and 1 is perfect. And they use that algorithm to produce this graph that looks a bit like a hockey stick. So as you're getting closer to an event, the sort of probability is just increasing generally. And then at a certain point, the probability is really becoming very, very high. And there's like a kink in the graph. That's the point that John Rundle says we should really start to worry and the real sort of predictive part of this.
So then could they use this model to, warn people, save lives?
So they haven't actually used their method to make any real-world future predictions just yet. First of all, they want to fine-tune their method on some more data sets, like Japan, for instance, has a really extensive, high-quality seismological record, but they're cautiously optimistic. But it's really important with these things to be careful. There have been many, many false dawns in the field of earthquake prediction. In the 1970s, researchers in China used certain indicators like water levels and whether animals are fleeing cities to successfully predict a 7.3 magnitude earthquake in the city of Haicheng. But a few years later, using very similar methods, they completely missed a 7.6 earthquake in another city called Tangshan. And in this one that they missed, hundreds of thousands of people died. And shortly afterwards, the monitoring program was shut down because it was deemed not to be successful.
So there really is a lot at stake then with these, and you can see why there might be sort of concern if something's a bit predictive but not really predictive. What's the reception been about this new technique from other experts in the seismological community?
So the seismologist that I spoke to said the team's work was fundamentally sound and the predictions they were making were probably accurate, but they didn't quite agree on how useful it might be. One expert I spoke to said it wasn't really specific enough to be useful, although when I put this to John Rundle, he disagreed with that and sort of quoted this hockey stick graph. But it's really too early to tell. They'll keep developing this method, testing it on future models, and we'll find out in the next few years, I expect.
let's take a quick break to tell you about New Scientist Live.
Yes, it's the world's greatest festival of science and technology. It's a fantastic event, and it's returning to London this year from the 7th to the 9th of October. And you can also attend online.
I'm really looking forward to a talk by author Emma Byrne called A Brief History of Your Brain. She'll be looking at how our brains rewire themselves in our first 2 decades of life and how that makes us the incredibly adaptable species that we are.
I'm excited to hear all about mathematician Agnijo Banerjee's quest to find the biggest number in the universe.
Yeah, that does sound really cool. You can go to newscientist.com/live to book your in-person or online tickets to this absolutely unmissable event. Will MacAskill is a philosopher at the Global Priorities Institute at the University of Oxford, and he became famous as one of the founders of a movement called effective altruism, which is basically a way to do good but do it better and more effectively. He's also become very involved in a related movement called long-termism, which, as the name suggests, is about giving priority to the long-term future. He's just written a book called What We Owe the Future, and Rowan spoke with him about his ideas.
Will, thanks for joining us. Now, I hate to make a philosopher sum up years of careful thought into a soundbite, but I'm going to have to do it. So can you tell us what is long-termism?
Long-termism is about 3 things. It's about taking seriously the sheer scale of the future that lies before us and how much is at stake there. It's about trying to identify what are the events that might happen in the course of our lives that could really impact the very long-term future. And then it's about trying to steer those events in a positive direction such that we put humanity onto a better course.
All of that is great. I guess the problem people might have with it is that it's hard for us to get people to act for the short term, isn't it? Like, we're thinking about 2050 net zero goals. We're in a pickle now because we haven't acted on climate change. I mean, shouldn't we concentrate on the current threats that we face now, like climate change and biodiversity collapse, pandemics?
All of those things are important in both the short term and the long term, as are other major issues like development of artificial intelligence, the possibility of a third world war. These are issues that will impact the short term as well as the long term. It's possible to make the long term go well at the same time as making the short term go well. Now, how do we get people to care? Well, I think people do care. When you look at disposal of radioactive nuclear waste, or if we think about just the projects that we might have in our own lives, like creating art or scientific inquiry, I think part of what we're doing is engaging in a sort of relay race where we have taken the fruits of centuries of work in the past, of intellectual discovery, of plant breeding, of artistic progress, and we're building on that and handing that to the next generation. And so I actually think that concern for the future is quite a big part of what motivates us and gives our life meaning anyway. And so I'm just kind of trying to build on that and say, yeah, if we take that seriously, then here are these like other things we should be concerned about too.
And you mentioned World War III there, and you talk about the threat of World War quite a bit in the book. And then since you've written it, Russia's invaded Ukraine. In the book, I think you said there was about a roughly 1 in 3 chance of World War III by the end of the century, which is shocking. I mean, is it even worse now?
There's a community prediction platform, Metaculus, that I rely on. According to that, in the next 50 years, there's about 40% chance of a war between great powers, with at least 10 million dead. And honestly, that seems about right to me. And we're not used to it because we've lived through 70 years of comparative peace. It's an unusual 70 years. But I think that a significant part, that's luck, because there wasn't a war between the US and USSR, but there were some very close calls.
There's a bit in the book about children and whether to have them or not. And I know a lot of people really struggle with this, with guilt about having children from a carbon footprint perspective or other fears of the future. Can you tell us a bit about your thinking about this?
Yeah, I really wanted to push back on this idea that it's wrong to have kids because of their impact on the climate. That's just focusing kind of only on the negative aspect of the ledger, as it were. So you have a kid, that's an enormous impact you're having on the world. You're doing all sorts of things. And some of that, for sure, is negative. People emit carbon, and that is bad for climate change. However, there's also the positive side. The kids will grow up, and if you raise them well, they will contribute to society. They will build infrastructure. They will innovate. They will pay taxes. If you bring them up well, they will be kind of moral change makers that will help move forward moral progress. These are all like important things, and I think actually add up to significantly more than the negative impact from carbon emissions. And then finally is just the benefit to the child themselves. And this is kind of a weird thing. I have a whole chapter on it. The best like philosophical view on this, where the arguments lead you, is to think if you can have a child with a sufficiently good life, a child that has a happy, flourishing life, then you have bestowed a sort of benefit on that child in virtue of them existing. And you've made the world a little better in virtue of that. And so when I think you take all of this into account, actually having children and bringing them up well looks like a way of making the world a better place.
I was really interested in your thoughts on shutting down coal mines. Tell us about that, because I think that the reasons are not what people might expect.
So why do we want to keep coal in the ground? I think there's three big reasons. One is obviously will reduce climate change. The second is air pollution, in fact, where the particulates from fossil fuel burning kill about 3.5 million people every year, and coal is the worst offender by far. But then third, and most unintuitively, I actually think it's just fossil fuels are a valuable resource that we might need in the future. In particular, if there were an event that caused civilization to collapse, so to go back to pre-industrial levels of technology and we needed to rebuild, then one thing that would be very helpful for that is having fossil fuels again. In terms of the best ways of achieving that, I've suggested this idea of buying coal mines and just trying to shut them down. And some philanthropists and activists are trying to do that. I think probably the best strategy is actually just investing in clean technology.
I'm just curious about whether you had a eureka moment when you were a child, maybe, or as a young adult, and something opened your eyes to the long-term future. Was there a moment like that, or was it something that just came to you gradually?
Honestly, I think this is something that has weighed on me over many, many years. And when I first encountered these ideas in 2009, I did think the ideas were kind of crackpot, if I'm honest. And then it was over the course of many years that the arguments just kept weighing on me that future people matter morally in the same way that present people do. There could be enormous numbers of people to come, thousands of times as many as there are people in the present day, and that there really are things that we can do to steer the future into a better direction. If there's one message I want people to take from what we owe the future, it's an optimistic one. It's that over and over again, if we look at history, we see that even small groups of actors really can make a long-lasting moral difference to the world. And I see concern for future generations as being one of the main next steps of moral progress, and something that I believe that in our lifetimes we really can make an enormous difference to. But that requires people like those listening to this podcast right now to really stand up and make a difference for the people who are yet to come.
That was Will MacAskill talking about his new book, What We Owe the Future, which is out now in the US and next week in the UK.
Next up, Michael, you've been reporting on how yields of soya have been boosted by more than a fifth by improving photosynthesis. Tell us about this story.
Yes, this is a fantastic piece of news. So the team has boosted yields without adding any fertilizer, and the soybeans contain just as much protein as normal, which matters because soya is an important source of protein. And so this means we can grow more soya without cutting down more forests. It's good for farmers, it's good for wildlife, it's good for the climate, and it's good for consumers. So just all-round good news. Everyone wins.
Woohoo!
Yeah, that really does sound like great news.
Yeah, and that's not all. This approach should work in other crops too. So the team's already modifying rice and cowpeas, and this work is also part of a global collaboration to develop other ways of improving photosynthesis. And by combining several different approaches, they think they can boost yields by more than 50%, which of course will be huge if they can do it.
Wow. So give us the science here. What do they actually do to boost the yields in these soya plants?
Essentially what they've done is to make the plants better at coping with the changes from full sunlight to shade and back again. So when a plant is in full sunshine, it's getting more light than its photosynthetic machinery can use, and that excess light can damage the cell. So the cell has to turn on this mechanism called quenching, which mops up the excess light energy. The trouble is when the plant goes into the shade, that quenching process can mop up light energy that it can now use, so it's got to be turned off. And the issue is the speed it takes to turn quenching on and off. If it takes a long time, you lose a lot of energy each time a leaf goes into or out of shade. So what the team did is they genetically modified the soya to produce high levels of three proteins involved in quenching. This speeds up those transition and saves that energy.
It seems so surprising, doesn't it, that such a sort of simple change, just 3 proteins, can make such a big difference. Why haven't plants evolved this natural ability?
Well, the short answer is some have. So it's recently been discovered that ferns can turn quenching on and off really fast. And that makes sense when you think about where they grow in the sort of dappled light under trees. But the thinking is with food plants is that their ancestors were grown in more open environments with few other plants nearby. Now we're sticking them in fields really right smack bang next to each other. And as the sun moves across the sky, most of their leaves are continually going into and out of the shade of other leaves. And the other bigger point to bear in mind with this is that in the wild, there's so many things that limit the growth of plants other than photosynthesis. So it's usually a lack of water or lack of nitrogen. And so evolution doesn't always necessarily select for the most efficient photosynthesis.
And you were saying that this will have environmental benefits too. Could you tell us more about that?
Yeah, so lots of people think of farming as some sort of green activity, but it's actually hugely damaging to the environment. Most importantly, a third of all greenhouse gas emissions come from farming. And one of the biggest problems, of course, is that we're still clearing more land for farms. Basically, the Amazon is being cut down to grow soya, to feed the cows, to turn into beef burgers. So the bottom line is, if you can grow more soya on less land, that means less rainforest has to be cut down for each of those burgers we like to eat.
I think a big question here is what kind of opposition there might be to introducing this kind of genetically modified, upgraded soya. What do you reckon?
Well, I mean, some people are opposed to GM crops no matter what. They've opposed the golden rice developed to reduce vitamin A deficiency, for instance. The thing is, in the case of soya, I don't actually think that opposition is going to matter much. So most of the soya grown around the world is already GM. And while GM soya isn't grown in Europe, GM soya is imported and fed to animals. So basically, pretty much anywhere in the world you buy a burger, there's a good chance it comes from a cow that was fed on GM soya. And hopefully soon those burgers will come from cows fed on this more eco-friendly, upgraded soya.
And finally, we've got a report on some weird weather on Jupiter's moon Europa. Leia, what's going on up there?
Well, it's not exactly weather, but it's close enough, and it's about how Europa's icy shell grew and evolved over time.
And so for all of us not completely up to date on our moons, Europa, that's a completely frozen moon, isn't it? But underneath its ice shell, there's probably a global ocean.
Yes, Europa is a moon of Jupiter that has this buried ocean, and since we can't directly study the ocean in detail, or really the shell from so far away, researchers had to find a place on Earth to use as an analog.
So it's got to be frozen with under ice sea, Antarctica, I'm guessing.
Spot on. Absolutely. This group of researchers studied the ice shelves in Antarctica to figure out what's going on beneath the ice on Europa. And what they found is that parts of the shell are probably made up of this super weird kind of ice called frazzle ice.
I love that name. What is frazzle ice?
So it forms when supercooled water in the ocean turns into these little tiny ice shards, which then float up towards the surface like a sort of slow motion upside down snow.
That's so weird and cool. So this is happening underneath the shell on Europa?
Yeah, probably. So that means that when these shards float up, they sort of land on the underside of the shell. So in some places, the underside of this ice shell probably has a weird landscape made up of ice flakes that are slowly compressing together into a mush. and, and frazzle ice is also way less salty than the water around it and the water that it freezes out of. So those areas of the shell would be much more pure than the ocean itself.
Okay, so there's this strange upside down terrain of really pure ice on the bottom of Europa's shell. What does that mean for, say, the potential of life there?
Well, it could actually be really good. they've actually found life forms, very basic ones, in these sort of poragey terrains in Antarctica. So it seems like they might be good environments for life. The thing we're not sure of yet is whether Europa's ocean is too salty for life.
And that's something that the Europa Clipper mission is supposed to help figure us out, right?
Yeah, that mission's scheduled to launch in 2024. And while it won't be able to sample the ocean directly, there'll be a bunch of ice in the way, it will be able to measure the salinity of the ice shell itself. So knowing how much of this super pure frazzle ice is in there should help us figure out how salty the ocean is.
And so that would give us a pretty good clue as to whether there could be life down there.
Exactly.
That's it for this week. Thanks so much for listening. Please don't forget to subscribe to the show and leave us a review. And if you want to read more about any of these stories, there are links in the show notes.
Before we go, don't forget the 50% New Scientist subscription sale. Visit newscientist.com/pod50 to check it out. And also look out for the latest issue of our magazine. The cover story is exploring the radical claim that plants may be conscious in shops now.
Thanks to our guests this week, Carissa Wong, Alex Wilkins, Michael LePage, and Leah Crane. We'll see you next week. Bye.
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 This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.